We always call Earth the blue planet, right? It looks like this big, beautiful blue marble from space, just covered in water. But here's the thing. At the exact same time, we're facing a massive, growing water crisis. How does that even make sense? It's a huge paradox, and today we're going to break down exactly why our water world is, incredibly, running dry.
So let's just state the central question right up front. If our planet is something like 71% water, how on Earth could scarcity even be a thing? Well, as you're about to see, the answer is kind of hidden in plain sight.
All right, to get to that answer, we need to peel back the layers on all that blue. It turns out the amount of water that's actually available for us to use is, well, it's shockingly small. The blue marble is a bit of an illusion.
And here's the first number that just stops you in your tracks. Of all the water on the entire planet, only 2.5% is fresh water. Everything else, salty oceans. But believe it or not, even that 2.5% doesn't really tell the whole story.
So, let's break down that tiny 2.5%. Most of that, we're talking the vast majority, is totally locked up, frozen solid in glaciers and ice caps. We can't get to it. And most of what's left is groundwater, very deep under our feet. So, what about the water we actually see and use every day? You know, the stuff in our rivers and lakes. Just look at this table. Add it up. It comes out to less than 1/100th of 1% of all the water on Earth. Let that sink in. Our entire global civilization is built on a tiny fraction of a fraction. Okay, so we've established we're dealing with an incredibly rare resource. The obvious next question is, where's it all going? Who or what is so thirsty? Because our global thirst is, well, it's absolutely massive.
A gigantic chunk of our fresh water goes into growing our food. Take rice paddies like this. They're basically these huge managed wetlands, and they feed literally half the world's population. It's a really powerful reminder that our food supply is completely 100% tied to our water supply.
And this chart really paints a clear picture of who the biggest users are. Just look at how the bars for agriculture and industry completely dwarf domestic use. Yeah, the water you and I use at home, it's just a drop in the bucket compared to this. Our whole modern way of life, from the food we eat to the phones in our hands, that's what's really driving this incredible demand.
So if the water in rivers and lakes is so unbelievably scarce, where do we get the rest to meet this crazy demand? Well, it turns out we've been making withdrawals from an invisible bank, one that's hidden right under our feet.
So how much are we really taking from this underground bank? Well, in the US, for example, while we get most of our water from the surface, a full quarter of our entire supply comes from groundwater. We are actively pumping it out of the earth just to bridge the gap between what nature provides on the surface and what we actually need.
But here's a term that changes absolutely everything. Fossil water. This isn't just regular groundwater. No, this is ancient water. It's been trapped underground for thousands, sometimes millions of years. And because it gets replenished so slowly, not in a human lifetime, it's basically a non-renewable resource. You have to stop thinking of it like a river that flows and start thinking of it more like oil, a finite resource you can only use once.
And to really wrap our heads around what this means, let's zoom in on a huge real-world example, the Great Ogallala Aquifer right under the central United States. This massive underground reservoir, it's beyond critical. It waters about 1/5 of all irrigated cropland in the US. But this map tells a really scary story. All those areas in yellow, orange, and especially red, that's where the water level is dropping. In those deep red zones, the water table has fallen by over 150 feet. It's literally disappearing. And this right here boils the whole problem down to two numbers. It's an unbalanced checkbook. On the left, that's the natural recharge rate. Nature puts back about 1.5 centimeters a year through rainfall. Not a lot. Now look at the right. That's us. We're pumping out about 15 centimeters a year. We're taking out water 10 times faster than it's being replaced. It's an absolutely unsustainable equation. For every dollar of water nature deposits, we're spending 10. That bank account is headed to zero.
And that's exactly why scientists have a special term for this. They don't just call it using the water. As this quote says, it's called mining the aquifer. We are extracting a finite, ancient resource to fuel our modern world.
Now, this isn't just about one aquifer in the American heartland. This kind of water mining is happening all over the globe, from China to India, and the consequences? They're serious, and they're spreading.
Here you can see a direct cause and effect consequence. On the left, there's that map of the shrinking aquifer. And on the right, that's the flow of the Arkansas River, which depends on that groundwater. You can literally watch, as the decades go by and the aquifer drops, the river's flow just gets weaker and weaker until some years it pretty much just vanishes. When we empty that invisible bank underground, the rivers we depend on up here on the surface can literally dry up and disappear.
And that is just the start. The effects just ripple outwards. The ground itself can literally sink. Crucial habitats for wildlife are destroyed. Droughts get even worse because we've lost that underground buffer. And of course, when a resource this vital becomes this scarce, the risk of conflict goes way, way up.
And look, this isn't just some future prediction. This graph shows it's already happening. The number of conflicts over water around the world is on a clear upward trend. What starts as an environmental issue is quickly becoming a major threat to global security.
So, let's just pull all of this together for a second. We've basically uncovered a pretty startling and kind of hidden truth about the world we live in.
Here's the key takeaway, the one thing to really remember from all of this. A huge part of our modern world, our food, our industries, is being propped up by a finite inheritance of ancient water. We are, quite literally, running our civilization on water that's older than civilization itself.
Which leaves us with one final and really sobering question. The system we've built is by definition unsustainable. We are mining the past to water the present. So what happens to all of us, to our future, when that ancient well finally runs dry?